In this video, we'll learn about the combination and logic tools of VMAM. Let's first open the software, where we can see that in the upper region of the main module, there's a button called Combination. We'll demonstrate the combination of the main module at the end of this video. Let's close it. So in the main module, we have this combination button, and in each camera, like. In our case here, we'll open camera 1 as an example. We also have a combination button, a logic button, and an interval button. In this video, we'll understand how these buttons work. Combination. Combination. Logic and intervals. Let's start here with the camera module. We'll use as an example in this video the output of a paper machine. 2 motion areas. Let's draw an area right here. We'll start. If there's movement inside, the result value will be 1. If there's no movement, the value will be 0. Head to region 3B. And start another motion area here. Here. Motion sensor region 3A and motion sensor region 3B. Create a logic and combination of the results of these two. Virtual sensors. We remind you that logic and combination can be done between any of the tools. We can combine object identification with motion identification with OCR identification with color identification. We can merge the data from all the tools into combinations to make the analysis more accurate. We'll start here with the combination button where we can see that the value 1 is where I can select my combination variable. This list of variables corresponds to the tools. In the manual, we have the complete list. For our case, tool 3A corresponds to this variable here. R3AR. For example, if I want to compare the variable from region 3A with the variable from region 3B, I come here to value 2 and select region 3B. Let's start the comparison. If region 3A is equal, here I can put any value, but I know it's A. It's a binary variable, 0 or 1, with 1 true. If region 3A is equal to 1, and the logic function and region 3B is equal to 1, my result will be positive, equal to 1. Or I can also use an OR function. Either this positive or that positive. My COM1 output result will be 1. Let's start with AND. I can configure up to 20 possible variables for output, with results in the software. being comb1, comb2, comb3, up to comb20. As we can see here, we can
Take a result, for example from comb1, and
evaluate it here as well. We can take this AND function and combine it with another variable 2. Initially, we'll work only with these two here with variable 1. I activate and start the combination. In our case now, when there's movement, in region 3B and in region 3A at the same time, the value of our output, comb1, will be 1. If I use the OR function, when there's movement in any of these regions here, the value will be 1. This is how the combination works. Let's wrap up. Now let's go to the interval function. In this interval, we have up to 10 possible variables named between HOR1 to HOR10, where I can select. For example, I want my variable 1 to be positive every day of the week. Between 8 a.m. and 11 p.m. at night. This variable 1 will be 1 at this time. Where can I use it? It's already set in place. For instance, if there's movement, comb1, I'll select my comb1. If comb1 equals 1 and my time value is positive equals 1, then my output will be 1. In other words, I can make region combinations
in one output and get the value of this output,
and combine it with the time output value and interval like. For instance, so the system works at certain times of the day. You can run this. Let's wrap it up here for now. Now we'll work with the logic. How's the logic?
Also here, 20 variables named log1
to log20, where we can select the variable we want. Whether it's a result of a combination or even our output. Three. We'll use output from region 3A. Several operators. Same as greater contains. We have stability functions, lookup functions, and so on. In the guide, we have explained how each of these tools work. In our case here, we'll use the equal to as an example. Instance, if the value 3a equals 1. The result value of this log1 result here, I, can select if it's positive. I want this value to be 1 or 0, or the variable's own value here. I have 3 options. In our case, I want it to be 1 if the value of my region 3a is equal to 1. I want the value of my result here to be equal to 1. I can also set a stabilization value.
For example, if I set 2000 milliseconds here,
the value here will only be 1 if the value 3a stays 1 stable for 2 seconds, then yes, it'll be 1.
here I have my time column that holds this value for the time I select here. For example, I can
select 10,000 milliseconds. It will hold the value here for 10 seconds. If it's positive here, I can also activate an analysis of another region. For example, I want to analyze if I found movement here. I want to analyze, for instance, the region 1a.
Region 1a needs setup.
It serves as a trigger to analyze region 1a, thus avoiding excessive processing of the only evaluating if there's a person there or not if there's movement, because motion analysis costs much less processing than an analysis of objects. And this last output value here is the value of how long the output that I selected here. The output values I selected here will be kept active. For example, movement detected. Movement was detected for 2 seconds. It was positive and initiated an analysis of region 1a. Identified as a person, and the person's value was transmitted to the region variable 1a, for instance. This person identification value here is maintained for the amount of time I set here. My case, it will keep region R1A R1 for 1 second. Very important, we also have here search functions. As we can see, this search function disables the volume so we can type here. How does it work? Below here, we have a database where we can insert searches with hashtags, like for example, license plates. Hashtag 1234. Let's insert another hashtag, WPM1234. I'll create a database with them. How does the search value work? If my region here, in this case, never. Our region 3a will give any of these values here because it's not OCR. Only if it were OCR. Let's simulate a value here from the OCR region, which would be region 2a like. If I had read
that here in my region, there was a region 2A.
Drawn and functioning. And a car stopped inside this region 2A. And the car's license plate matched any. 1. Of the records in the database. The value of my output logic can be 1, it can be 0, it can also be the value of the variable in text. And so on. Here we have a stability tool that, just like this one, serves to stabilize the output value. For instance, if the output value here is stable, for 2 seconds, my logical output here will be 1, 0, or the value of my own output. In this case, since the stabilization value here is 2000, it will have to be 0 because we have 2 types of stabilization adding up to 2000 milliseconds here with 2000 milliseconds. This stabilization function is just a stabilization function for any value within of my selected variable here. And so we have several other operators that are explained in the manual. Remembering that just like the combination region, we have to activate and start the analysis. This activate button must always be on, as we can already see in the training in any active tool. The same thing happens in the main module combination. However, in the main module combination, I can choose the camera, where we can see the 16 cameras here.
I can choose the inputs
for analysis. Of artificial intelligence. OpenAI, Anthropic, Gemini, and combine them with other outputs. Remember that in the manual we have the complete mapping of these variables. Let's pick camera 1. When we select camera 1, we have here
20 variables.
From camera 1, what are these variable values? From camera 1. Let's close this for now. We go back to camera 1. We have a window called transmission. In the transmission window, we have here 20 variables, the values read in the main module. Are the values transmitted in the camera module? For our case, the variable 1 will be region 3A. Variable 2 will be region 3B. Movement region 3A. Region 3B. For the data from these variables to be transmitted to the main module, we must
Start the DB file transmission.
where we activate and start the transmission every 200 milliseconds. Once that's done, these values are being transmitted. We can close here. For variables 1 and 2 configured here, for example. In this case, we have cam1 variable 1 equal to C1 will be positive.
And cam1 variable 2
Equal to C1 will be positive.
It'll be 1.
We begin. And the analysis of variable 1 here, where I'm hovering, is being analyzed as well.
Being analyzed here in the region.
In the module. However, we could, in the main module, make these same combinations.
With different cameras. For example, we can
Combine the movement of camera 1 with the movement of camera 6. Since camera 6 is not active, the values don't appear here. Let's see if we have values here from camera 2. In this case, we can combine the values of camera 1 with the values of cam 2. Remembering that for the values to pass to the combination main modules combo, the values must be enabled. In the transmission through the DB file transmission, enabling it and starting the analysis.